Okay, there's several rules that electrons abide by, and they're listed on your green sheet at the bottom here. You've got the Aufbau principle, the Pauli exclusion principle, and the Hund's rule. So what I want you to identify are key concepts under these principles on your green sheet so that you can identify them. You've been practicing and applying the Aufbau principle because you have the order and they go in lowest energy level first. So if you just did 1s, 2s, 2p, 3s, 3p, and instead of switching these two, you did 3d and then 4s, then you would be violating the Aufbau principle. Okay? The Pauli exclusion principle is that an orbital can only contain 2 electrons. So if you know S has 2 orbitals, that means it can only have, if S has 1 orbital, it can only have 2 electrons. We know P, go back up here, has 3 orbitals. 3 orbitals, each having 2, can give it 6 electrons. So that's why P holds 6. D has 5 orbitals, 5 times 2 gives you 10, and so on. The Hund's rule is related to using orbital notation. And orbital notation is, instead of representing our electrons as 1s2, 2s2, 2p6, we indicate that in box format or lines. So each orbital is represented by 1 line. So 1s would have 1 line, 2s would have 1 line, and 2p would have 3 lines because it has 3 orbitals. Remember, each orbital can have 2 electrons, and the electrons happen in opposite spin. So whenever you put in your arrows have to be in opposite position because it just allows the orbital to maintain some sort of stability. If both electrons were in the same direction, all the energy and all the flow would be going in that same direction and the orbital could spin out of control. So that's what Hund's rule is. Hund's rule applies to the arrows here. And the basic thing that you should know about Heisenberg's uncertainty principle is that we don't really know where electrons are when we're not actually looking for them. But we do know that they have some general probability of being in a certain energy level, a certain orbital, and a certain sublevel. Okay, so that uncertainty principle leads us to this electron configuration here, or the orbital notation here. The next 3 slides are just bonus information about what these sublevels actually look like. Okay? What are sublevels and orbitals? What do they look like in an atom? Okay? So what you're seeing here is the various sublevels. You've got the S sublevel, the P, and the D. Remember, within those sublevels, you have orbitals. The S orbital is just a sphere. The P orbital is these 2 figure 8 lobes that go along 3 different axes. The X, the Y, so here's your X, here's your Y, and this one is representing the Z-axis, which comes in and out of the screen. Okay? D has 5 different directions. Okay? And in addition to that, it has a parallel double lobe. Okay? So you've got your X, you've got your Y, you've got the Z, and then you have these other zones. Here's a more colorful image of the various lobes, as well as combining the 3 different axes into one general